If you've seen the movie Interstellar, you definitely remember that wild climax where Cooper falls into the black hole, Gargantua, and he doesn't die. Instead, he winds up in this bizarre five-dimensional space. It's an incredible scene for sure, but it really makes you wonder how much of that is based on actual science. So today, let's explore the chilling, mind-bending truth about these cosmic giants.
Yeah, that's pretty much the image we all have in our heads, right? These terrifying cosmic monsters. They represent the ultimate unknown, these dark voids with a gravitational pull so ridiculously strong that absolutely nothing, not even light itself, can get away.
So was Interstellar onto something? I mean, if you were to actually take that plunge, would you find some kind of gateway to another dimension? Or would you meet a much quicker and way more violent end? To get to the bottom of this, we've actually got to rewind the clock by over 100 years.
You'd think the story of black holes would start with an astronomer staring through a massive telescope, right? But nope, it all starts in the mind of one person, Albert Einstein. It was his revolutionary theory of relativity that first predicted their existence, even though he had no idea they were actually real.
And just think about that journey, from a wild idea on paper to an actual photograph. It all kicked off in 1905 and 1915, when Einstein proposed that both speed and gravity could literally bend time. For decades, it was just this mind-bending concept. It took until 1964 for someone to even coin the term black hole, and all the way until 2019 for us to finally capture an image of one.
So here's the absolute game changer from Einstein. Time isn't constant, it's relative. The first way it slows down is with speed. But the second way, the one that's crucial for black holes, is gravity. Remember that water planet in Interstellar, where 1 hour for them was 7 years back on the ship? That wasn't just Hollywood magic. That was gravitational time dilation in action, all because they were orbiting so close to the immense gravity of the black hole.
To help us wrap our heads around this, Einstein gave us this brilliant picture. Imagine the entire universe is a giant, stretchy trampoline. Now, if you put a bowling ball, like a star, on it, it creates a dip. That dip is what we feel as gravity. But a black hole? It isn't just a dip. It's like taking a razor blade and slicing a hole right through the fabric. It's a point of almost infinite depth that warps not just space, but time itself.
So how do you even make one of these universe-bending objects? Well, it turns out they're born from the incredibly violent death of the biggest stars in the cosmos. But first, let's get something straight. The name black hole is, well, it's kind of terrible actually. It makes it sound empty, right? Like a hole in space. But it's the exact opposite of empty. A black hole is an unbelievable amount of matter squeezed into an impossibly small space.
The process is this epic cosmic tug of war. It all starts with a star that's way, way bigger than our sun. For millions of years, the nuclear fusion happening in its core is pushing outwards, fighting against the crushing force of gravity pulling inwards. But eventually, the star runs out of fuel. And when that happens, gravity wins. And it wins in a big way. The core collapses, triggering a massive supernova explosion, and what's left behind is that ultra-dense remnant, a newborn black hole.
To give you an idea of just how dense we're talking, imagine if we could somehow crush our sun down into a black hole. It would be a sphere just 50 kilometers across. Now, lucky for us, our sun isn't nearly big enough for that to ever happen. There's a certain mass a star needs to have, and ours is well below the limit. It's going to become a white dwarf instead. Phew.
All right, so we know how they're born. Now let's take one apart. What are the different components that make up a black hole, and what would we actually see if we dared to get close?
Okay, so not all black holes are created equal. They come in different flavors. The most common ones are stellar black holes, which are basically the leftovers of a single giant star. But then you have the supermassive ones. These are the real titans, millions or even billions of times heavier than our sun. They're the ones lurking at the center of pretty much every galaxy, including our own Milky Way. The other types are still mostly theoretical, kind of in the maybe pile for now. So if a black hole is black, what's that crazy fiery ring we always see in the pictures? That's called the accretion disk, and it's really the only part we can see. It's this massive whirlpool of gas and dust that's being pulled in, spinning so incredibly fast that friction heats it up to millions of degrees, causing it to glow fiercely with radiation like X-rays.
And that first real picture? It shows us some amazing stuff. You see how one side of the ring is brighter than the other? That's because that's the part of the disk spinning towards us. And that warped, halo-like shape, that's an optical illusion.
The black hole's gravity is so powerful it actually bends the light from the back of the disk up and over the top so we can see it.
If you get even closer, you reach something called the photosphere. Now, get ready for this because it gets weird. This is the last possible stable orbit for light itself. Gravity here is so extreme that photons, particles of light, are trapped, forced to just circle the black hole forever. This creates an unbelievable effect. Light from the back of your head could literally wrap around the black hole and re-enter your eyes from the front. You could see the back of your own head. Wild.
We've been skirting the edge, but now we're going in. From this point on, there is no turning back. We are about to cross the boundary from which nothing and no one has ever returned.
This is it, the event horizon. It's important to know this isn't a wall or a membrane you'd crash into. It's just a line, a threshold in space-time. The moment you cross it, the pull of gravity becomes so immense that escape is physically impossible. The speed you need to escape is faster than the speed of light, and since nothing can travel that fast, you're trapped forever.
Okay, so what about that 5-dimensional library from Interstellar? Well, this is where the science ends and the science fiction begins. It was a beautiful, really imaginative idea for the movie, but the honest truth is, we have absolutely no clue what lies beyond the event horizon. Our rulebook for how the universe works literally stops right there.
Now, according to Einstein's theories, at the very heart of it all is something called the singularity. This is a point of supposedly infinite density, where that space-time fabric we talked about is stretched to infinity. At this single point, all of our known laws of physics, everything we use to describe reality, they just break. They stop working.
So let's finally answer that big question from the beginning. What really happens if you fall in? Well, the scientific consensus is it would not be a good time. The gravitational forces would stretch your body like a piece of spaghetti, tearing you apart atom from atom in a fraction of a second. No Tesseract, no messages to the past, just instant, total oblivion.
But hey, before you have nightmares, here's some good news. Black holes aren't cosmic vacuum cleaners just roaming around gobbling up the universe. They obey the same laws of gravity as everything else. If you stay a safe distance away, you can orbit one just like the Earth orbits the Sun. Just, maintain a very, very safe distance.
And that leaves us with the biggest, most exciting mystery of all, the singularity. Is the place where Einstein's physics ends. But that doesn't mean it's an end. It means there must be a new, more complete theory of the universe waiting to be discovered. So what is it? What incredible secrets about our own reality are hidden inside the deepest, darkest objects in the entire cosmos? That is a mystery for the next Einstein to solve.